You know what page it is? You know what we've been talking about. Let's get into this one. Complementary relationships. Consider triangle ABC with right angle C. By the way, highlight time. That's going to make side C the hypotenuse, and we should label it. Hype. All right, there it is. Hype it up. Angles A and B are complementary angles because the sum of their measures is equal to 90. So that's the big idea. Complementary means the two angles add up to 90. And of course, they have to add up to 90 degrees because all three angles in a flat triangle add up to 180. One of them is 90, so the other two have to also add up to 90. The trigonometric ratios also have a complementary relationship. Let's say we're going to focus on reference angle A, so this color. And then because of that, that's going to label, the hypotenuse stays the same, but it's going to label side A as the opposite and side B as the adjacent. So far, this is my recommendation for labeling the angle and then the sides of a right triangle. Theta goes first. There it is. Then the hypotenuse, then the opposite, then the adjacent sides. And once you've got them labeled mentally or on paper, after that's done, then we can write out our sine ratios. So for example, sine, cosine, tangent, etc. So sine, toa. Sine is the opposite side divided by the hypotenuse, which means sine is A over C. Cosine from angle A is going to be the adjacent side, B, divided by the hypotenuse. And then tangent. Tangent is the opposite over adjacent. So from angle A, the opposite side, and then the adjacent side. We've explored all of that in lessons 2, 3, and 4. In fact, we've also explored cow, as in cosecant, secant, and cotangent, because it's just the reciprocals, right? This is just switch 'em. That's all we're doing for secant, cosecant, and cotangent. Cosecant is hypotenuse over opposite side. So it's the sine fraction, but flipped. Secant, as in secant is hypotenuse over adjacent side, is the cosine fraction, but flipped, which would be this fraction, which would be flipped. And cotangent is the reciprocal of tangent, so therefore your opposite adjacent relationship becomes adjacent opposite. And from angle A, that would be adjacent opposite. Did you catch that? Because I'm going to ask you to do that in angle B. We're going to change our reference angle to angle B now, which changes our opposite side to side B, and changes our adjacent to side A. Little labeling, cross it, adjacent, cross it, and opposite. Will you go ahead and right now fill out from the reference angle B, the sine, cosine, tangent, cosecant, secant, and cotangent for angle B? You're still here, so I'm going to do it too. But thank you for, if you did pause and you're just going to skip around, that's the right thing to do. You should be practicing for yourself. See if you can do this part. And thank you if you did. So the sine of B would be opposite over hypotenuse, B over C. The cosine of angle B would be the adjacent over the hypotenuse. And then the tangent of angle B would be opposite over adjacent. So then cosecant would be hypotenuse over opposite. Secant would be hypotenuse over adjacent. And then cotangent would be adjacent over opposite. We can right now summarize the relationship between the trigonometric functions of complementary angles. So for example, notice these two are the same. These two are the same. This one and this one are the same. Tangent of A and cotangent of B are the same. Cosecant of A is equal to secant of B. Secant of A is equal to cosecant of B. We only really need to memorize 3 fractions. Because every other fraction is some reciprocal or equivalent relationship. Yo, I just did number 2. We only need to memorize. Maybe you pause for a minute and let me write this out, and then you skip forward, okay? To memorize or identify 3 fraction relationships. Because all 12 relationships of complementary angles are either equivalent or reciprocal to those 3 fractions. Why is the ratio for sine of angle A equal to the ratio for cosine of angle B? Reference angles opposite and adjacent are switching sides when the reference angles are switching sides themselves. So therefore the cosine was defined by adjacent side, but now when you switch to the reference angle, that adjacent side now becomes the opposite side. Why is the ratio for cosecant angle A equal to the ratio of secant for angle B? When you change the reference angle from one acute angle, you establish that the original adjacent and opposite sides are trading places. So therefore, your cosine of angle A defined the adjacent side next to that angle. But then when you move that reference angle over to angle B, what was an adjacent angle to angle A is now an opposite side to angle B. So therefore your cosine and your sine would be identified, your secant and cosecant. They'd be referencing the same numbers, but they're referenced from a different reference angle. Why is the ratio of the tangent of angle A equal to the cotangent of angle B? I'm not repeating what I said. It's all about the reference angles, people. It's all about the reference angles. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Thanks for liking, commenting, and subscribing and watching this video. See you in the next episode.